This I think would be a cool little project for you and some kids. This is a theremin. If you don't know what a theremin is, that's okay. Not many people do. An electronic device that I don't know if it uses capacitive impedance or resistance in the air when you wave your hands over and it makes a noise. That's all it makes. It's just a whining noise. Saw this on Amazon, I think for like $35. I thought it was kind of neat. MicroKits makes them. It has 30 parts, no tools needed, assembled and made in the United States. Well, parts are not made in the United States. It's put together in the United States. They give you 3 AA batteries. It's packaged really well. So yeah, I wanted to put this together and see how it goes before I introduce it to a friend. Let him use it and let him play with it. It has a very detailed, chosen by the looks. Got stickers, that's cool. Have model kit number 3951, so they've almost sent out 4,000 of these. We guarantee your kit and replace any missing parts for free. So yeah, this is awesome. So like 4,000 people have, almost 4,000 people have had this kit. And I kind of wanted to make a video of putting it together and whatnot and talking about it. There's a little breadboard, A, B, C, D, F, G, H, I, J, positive and negative terminals on both sides for your bus bars, and a foam padding. I'll get back to the book here in just a second. I'm going to go through this. Here's your on-off battery pack. It's very basic. You can buy these from China. AA battery, Panasonic, and heat shrink. We'll make sure that we get these opened. I highly doubt they packaged these batteries up like this. It probably was already pre-packaged and they just bought it and put it in a kit. There we go. I'm just going to go ahead and put it in the battery case. That way we don't have batteries loose laying around. Which is probably part of one of the steps, but it's okay. Don't necessarily need a kid putting batteries in. They don't know what to do. And turn it off. It has jumper wires that you could put into this. Here's your 2 chips and a speaker. I want to note that these are in anti-static bags and has an anti-static foam, which is amazing. And so they have tick and micro. And it's a label. I wondered what that was. It's just a label they put on here. And I kind of wanted to see Texas Instrument. Oh yeah, it's a 556 TLC 556 timer chip. Okay, that makes sense. And here's the micro. Let's see what's under the micro. I mean, I'm not giving away trade secrets. Anybody can buy the kit and do the same. You're not going to get rich off of making something like this. Not many people build a theremin let's see what under label number 2 for the micro. A big old logo on the chip. I'm not familiar with that just yet. What is that? Oh, that's the eyes. They got, okay. And I would just have to scrape the eyes off and see what the microchip is, but it's a 2 something. I'm not afraid of taking the eyes off. We are an electronics channel and we want to learn about everything electronics, correct? It's like 2E571. And this actually might be a programmable little chip. I'm not sure. We'd have to look this up. But cool. Anyway, I'm gonna look at that. Pre-cut jumpers, which, hey, great, amazing, love it, because you don't have to worry about showing a kid how to put the jumpers and bend them and cut them and all that mess. It's perfect. Pre-stripped, pre-bent for these as well. That's just amazing. Can't thank you enough for that. Now let's get back to the most impressive installation kit I've ever seen a manual of. This is awesome. Love it. The illustration, just, yes, this is exactly what you need to do when it's teaching younger people that want to get the basics knowledge of working on electronics and stuff like that. This is what you need to do. This is amazing. This is awesome. I love it. So, kudos to you guys for doing that. I really appreciate the effort you went into doing this. I'm going to pre-assemble it, then I'll take everything apart and give it to little buddy and let him play with it, and he can keep it after I get done playing with it myself. So let's look at some of these parts here. It's gonna be a half-hour video of rambling. We want to just show how to put things together. So we're going to put this together step by step. We have 2 little orange guys, and you have a little capacitor and some red and blue jumper. But they talk about, okay, here's your antenna, here's the jumpers, here's this, here's that, here's the 3 resistors, transistor, 2 capacitors, LED, tick and micro, that's him, speaker, breadboard. We're building a circuit in different stages and adding different functions as we go. That way we can check our work. Don't worry about making mistakes. We can fix them along the way. Okay. So I am going to move these off the paper so we can do this. So stage 1 is power and LED. Stage 2 is audio. Stage 3 is pitch and volume. So we're going to go through all that. Capacitance, that's how that works. That's what I wanted to know. So a 1930s RCA theremin. The theremin creates music and sound at a distance without touch. Moving your hand towards the right antenna plays higher pitched notes, and moving towards the left antenna decreases the volume. In 1920, an engineer named Leon Theremin invented this instrument. Since then, it's been used to create experimental music and eerie sound effects and inspire many electronic musical instruments. So it uses capacitance in order to create these sounds. We're going to go on. So it's talked about on the breadboard. This is point F3. So here's the F row all the way down. and here's the number 3. So you're going to go over here to F3. That's how that works. So if they want A12, then you'll go to A12. Or C18, when you go to the C line and there's your 18, you cross it over. That's the basics of how a breadboard works. See? It's very simple. So, they want us to get Mr. Looks like Micro here. Nope, they're just talking about it. Okay. Now we're talking about the positive and negative grids. Here's your positive and negative grids. Positive would be pink or red. Your negative on this one is blue. And we're talking about the grid, and we're talking about the power. Okay. Gives a little history about this. The first breadboards were made from wooden bread cutting boards. I did not know that. I've been working with electronics for 22 years, and I learned something today. That's pretty good. So we are going to get Mr. Micro out. I've got Mr. Micro out. Pull him off the memory foam. And we're going to place him on pins in the rows 14 to 11, columns E and F. Make sure the eyes are pointed down. So we'll go between E and F and 11 through to 14. So E and F is the channel here. I'm going to start on pin 11, and that's going to end at 14 as the 4 pins on both sides of the chip here. And that's how that goes. And then you have your 2 jumpers. One's going to be negative and one's going to be positive. So it's a positive line. The positive is this whole line here, and the negative is the opposite. So they want you to go positive. It says, let's see here, from A14 to negative. I'm going to use an orange jumper. So these whole lines here, so like the row 1 here, all of these are all connected internally. So if you take and put one jumper here to another one, everything on that row will be powered. Obviously separation is in between, meaning these will not be connected to each other unless you put a jumper in it. So A14 and J14. Positive for J14 to it's the pin here, J14. We got one leg into the 14, and we're going to get the one other leg over here to positive. Just like that. I'm going to do the same on the opposite side for your ground. A14 and the little bus bar here. Okay, that's it. And I want you to put this capacitor across it. And usually they have a polarity, but these do not. We'll put him down in 20 just because that's what they want you to do. Down here by 20. And there's what that is. Okay, so now we have an LED. That's what this green guy is. You have a short leg and a long leg. And a flat side. You see there's a flat side on this diode? Yeah, that would be on this side. The LED has a positive and negative side. Connect along the positive wire to J12, sorry. and the shorter to the negative. So they want you to take and go, here's the J line, here's 12, I'm going to move it over here to that. It's just like that. Direction matters, it says. Light emitting diode. So it just will light up. You know what an LED is. You've seen them around. Once you see what this says, you'll know what it is. Okay, so we're going to move on to the next page. This is the power and LEDs. Now we can take and put positive switch and negative. And it's probably going to do is just turn on. So now we're going to have it off, turn the batteries in, which I already put the batteries in. So, when you're ready to turn the power on, what happens? You'll know if the circuit's working or not if the LED lights up. Well, my LED's not lighting up. So what did I do wrong? Okay, so I had to take and put this LED across on the ground over the chip, and you see that the LED lights up. So I don't know if there's a bad bus bar or what there is, but we will find out. Okay, so yes. Alright, so there is a bad bus bar. The ground on this side is bad on this breadboard. Verify that by putting this over here, same negative. Gotcha. Alright. So here's key important that I missed and flat out missed it, which may make a difference in why this did not work, and I think entirely it will. So I'm going to put this back over here because I missed this instruction right here about putting the positive wire across and the negative wire. And now that may make the entire difference in what my problem was. I skipped over that step, and let's see what happens. Alright, makes sense now. Red wire from less positive to this, so might want to reword that to place, instead of just saying orange wire from blah 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 blah, place this orange wire to this, place this, place this, place this, and it's instructional instead of red to this to that. You just got to think of a child, and you know, I'm 38 years old, and I flat out missed that myself. It's my own fault. Alright, so the LED works. And next is the audio. Turn power off. Place the capacitor from B14. There's one more capacitor. B14 to B15. like that. Find a green, blue, brown colored resistor and place it from C12 to C15. The green, blue, brown, here it is. C12 to C15, which is again, I did not do the instructions right. I went up instead of down. I'm on 13. Only thing I wish was the parts was a little bit larger for the capacitors. That way I can actually grab onto them. Tweezers will work. So C12 to C15. There we go. There's that. It says resistors resist the flow of electricity. You know, it resists current, yes. Purple wire from A16 to A23. There are 3 purple wires, one darker than the other 2. And I'm not sure if that's on purpose or if that's a blue or what that is. Okay. So I'm going to put him off to the side because it says 3 yellow and 8 red, 8 oranges. So we have 1, 2, 3, 4 yellows. That's an extra one. And orange, there's 8 of them. 1, 2, 3, 4, 5, 6, 7, 8. I've already have 2 in there, so I'm going to take 2 of these wires out. Okay. Well, now back to the purple wire. This is darker than this, which makes no difference. But if you're trying to put it together, it might confuse somebody. Purple wire A16 to A23. I love how precise every wire is cut. They were spot on with that. Now we have the transistor, which is this little black guy here. And he is a 2N3904. Just for reference. And we're going to go just like this. Yep. Transistors turn on a small amount of electricity on one pin into more on another pin. Here it makes the speaker louder. A transistor works exactly like a light switch. The center pin is your bias. It has a 0.7, I believe, 0.7 volts difference to turn it on or off. It might vary from different transistors. But beyond that, it's a switch. So when you turn the middle gate on, it allows the electricity to go from one side to the other. That's all the transistor will do. You can do pulsating, you can do all kinds of things with it. Next is the speaker. The speaker has 2 pins. It's got a positive and negative. It has E23 and G23. So we're going to go across. So here's E. And we have to make sure G, E and G. I'm guessing it's in G because I can't really tell. Yep, it's in G. Nice size speaker. Double check your work, then turn power on. If you hear nothing, turn it off. Troubleshoot for mistakes. If you hear a constant tone, your speaker system is working. I hear nothing. Alright. We're doing good. I guess I should see if orientation of the speaker matters. We will put the positive over here on the 23, on the E23. I don't hear nothing. Okay, let's make sure. Yes, I missed a step. Orange wire from J23 to positive. That's why we don't hear anything on that. And I guess it does matter. It shouldn't matter where this comes from, but it is if you're trying to get it to get right on that notch. I'm gonna go this way. It will still make now we got it. Average the tone. With power from the battery, I create an electric wave that goes to the speaker. As the electric wave increases and decreases, I move an electromagnetic in the speaker up and down, pushing the air to create the sound waves you hear, but I'm only playing a single note now, so let's add parts to build the real theremin. So these are called square waves, and that's just kind of like a sine wave. Now we're really getting intricate here with more wires and more resistors. Turn power off while building. You don't want to sit there and listen to it squeal. We're going to get the little chip out. Place tick on rows 1 through 7, which is the very top. Eyes go down. Orange wire from J1 to positive. Here's J1, here's positive. Come on. And then we're going to go J5 to a positive. The next will be to negative A7. Okay, we got that down. Now let's go to the next one. Yellow wire from G3 to G7. This is over here. Here's 7. 3 is right there. Purple wire from H6 to H13. There's a 6, 13, perfectly lined up. Again. find the yellow, violet, orange. So yellow, purple, orange. From I3 to I6. Here's the I6, I3. Color bands. The code for how much they resist in ohms. That's right. Colors above mean 473. 47 with 3 zeros at the end means 47,000 ohms. There are the color code things. So if you get into electronics, that's what you need to look into. So what about the other wires? Did I miss them? Only two resistors, and we have a bunch of extra. 2 orange and 2 yellows. Okay, great. Place one of the antennas into J3. Bend it to any shape you want. This is the pitch antenna. I'm just going to bend it like that. When ready, turn the power on. What happens when you reach towards the antenna? If the note stays constant, turn it off. Troubleshoot like before. If the pitch increases as your hand approaches, congratulations, you made it working theremin. Okay. So we're not done yet. So we're going to test that theory out. Awesome. A noise that will infuriate the parents and the child as you give this to. And it goes on and talks about the different waves now, the signals. So we have one last couple step here. Let me move my antenna, and I bumped it. Turn power off, of course. You don't want to sit there and listen to it squeal. We have the last resistor, B2 to B5. Here's B2, here's B5. Okay. Yellow wire from A4 to positive. A4 to positive. Yellow wire from D2 to D6. Just like that. Now we have 2 orange wires left. Orange wire from C3 to C8, C5 to C8. And B8 to B11. You have one last wire. Like the second antenna to A2. Here's A2. And I'm going to bend it down over here. And that's the volume. Okay. So stick out from the side and away from the board, away from the stuff. And this antenna will just keep over here. Turn power on. What happens when you reach towards the antenna? The volume stays the same, turn it off. If volume decreases, to move your hand towards the volume antenna. You've successfully completed your theremin. Now it gives you the blueprint, the circuitry that talks about, and that is a microcontroller. So that was, it's pre-programmed, so that's good, cool. And it says 556, so it's not really breaking any code. It says, oh, this is what it, no, cool, Awesome. So for $35, and if you don't know how much a theremin usually costs, it's ungodly expensive. There's an excess parts, which is cool. You might lose whatever. Let's see how this works. Now you can see okay, I'm going to turn it off before the wife killed me. This has been awesome. It's challenging. It will make whoever puts this together think. This is an awesome thing for getting children or anybody into electronics and learning how to do this. I really enjoyed it. It's kind of, I mean, the instructions are clear. You have to pay attention, which is something I may not be doing right. But yes. Does it work? Yes, it works. Is it cool? To me. Yes, it's very cool to me. Thanks for watching, guys. I highly suggest you go out and buy yourself one of these. We'll see you next time.